Hello everybody, this is Mr. Donaldson. We're continuing our video series on transformations. The first one in the series was translation, which was to slot an object. Then we covered reflection, which was to flip an object. Now we're going to look at rotation, which is to turn an object. And the next video will be about dilations, which is to make something larger or smaller. But today we focus on rotations. Here are our vocabulary terms for this lesson. Again, we have the word transformation, which is the movement of all points of a figure on a coordinate plane, according to the same operation. Today's new words are rotation, which is a transformation that turns a figure about a fixed point through a given angle and a given direction. Angle of rotation. This is the amount of rotation about a fixed point. And we have congruent figures. These are figures that have the same size and shape. Here are three examples of rotation. In the first one, we have the top triangle, and it was rotated to make the bottom triangle. In the second one, hopefully you see that this is the original shape because of how it's labeled, and it was rotated up to make the new shape. Finally, we don't know which ones are the original shape in the third example, so we could have turned that bottom one to make that, or the other way, we could turn the top one to make that. So those are your examples of rotation. Let's start talking about direction and degrees of rotation. We have clockwise and counterclockwise. Clockwise moves in this direction. Counterclockwise moves in the opposite direction. Now it's time to talk about degrees of rotation. Typically you will see either 90 degrees, 180 degrees, or 270 degrees of rotation. 90 degrees would be a quarter turn. 180 degrees would be half a turn, and 270 degrees would be 3/4 turn. And then your direction. So let's look at the blue triangle. If I wanted to rotate it 100, let's start with 90. If I wanted to rotate it 90 degrees clockwise, I would go from that quadrant 2 to quadrant 1. That's a quarter turn. If I wanted to rotate that same blue triangle 180 degrees clockwise, I would go from quadrant 2 to quadrant 4. Finally, if I wanted to rotate the blue triangle 270 degrees clockwise, I would go 3/4 of a turn. There's 1/4, 2/4, 3/4 of a turn, and it would end up in quadrant 3. Now let's look at counterclockwise. 90 degrees counterclockwise would be 1/4 turn. 180 degrees counterclockwise would be half a turn. And 270 degrees counterclockwise would be 3/4 of a turn. So basically think about each quarter being a new quadrant. For these two examples, let's see if we can figure out the direction and degrees of rotation. In the first example on the left, I start with my original figure, and I see that this figure was turned there. So first, was that a 1/4, 1/2, or 3/4 turn? I only moved one quadrant, so that was 1/4 turn, which is 90 degrees. We moved to the left, so that was counterclockwise. So this first shape was rotated 90 degrees counterclockwise. For the second one, I start with the shape in the bottom left, and I went 1, 2, which would be a half turn, so that's 180 degrees. And did I go clockwise or counterclockwise? Well, here's the interesting thing about 180 degrees. It doesn't matter the direction. So this was rotated 180 degrees. Here's how you actually conduct a rotation mathematically. I would highly recommend you take notes on this section. This can be a bit confusing and tough to remember, so until you memorize it, you will definitely need to refer back to your notes. When rotating 90 degrees clockwise, you take your XY point, which is our original coordinate, and you're going to make it y, negative x. So you're going to swap the y and x and make the x value negative. For example, 1, 2, we swap it, which would be 2, 1, but we have to make the x negative, so it would become 2, negative 1. 180 degrees, you take the xy, and you just change the signs, so it becomes negative x, negative y. For example, 1, 2 becomes negative 1, negative 2. For 270 degrees clockwise, we take xy, and what we do is swap the y and the x and make the y negative. For example, 1, 2 becomes negative 2, 1. Here are the rules for rotating counterclockwise. 90 degrees, xy becomes negative y, x. So our example 1, 2 becomes negative 2, 1. 180 degrees, the xy, just like in the previous one, we just change the sign, negative x, negative y. So 1, 2 becomes negative 1, negative 2. Finally, 270 degrees, xy, we swap the order y, and make the x negative. So it would be y, negative x. So 1, 2 becomes 2, negative 1. Now let's compare the clockwise rules to the counterclockwise rules. First, let's look at 90 degrees clockwise. Do I see anything else that is similar to counterclockwise? If you look, you will see that 90 degrees clockwise is the same as 270 degrees counterclockwise. We've already discussed how 180 degrees clockwise is the same as 180 degrees counterclockwise. And finally, we see that 270 degrees clockwise is the same as 90 degrees counterclockwise. So that means you only have to memorize a few of them and not that whole list. 90 degrees clockwise is the same as 270 degrees counterclockwise. That means when you see this rotation, you take the x and y, then you swap it and make it y, negative x. For 180 degrees in either direction, you take the xy and just make them both opposites, negative x, negative y. And finally, when 90 degrees counterclockwise or 270 degrees clockwise, you take the xy, swap them, and it would become negative y, x. So if you just remember these three, then you'll have it down pat. Here's how it works. I have a graph with a triangle, and I need to rotate it 180 degrees about the origin. When I look back at my rules, when I rotate something 180 degrees, that means I'm going to take my coordinates xy and I make them opposite. So it becomes negative x, negative y. So what I'm going to do is list each point and just apply my rules to them. Here are my 3 points for this triangle. H is located at negative 3, negative 5. J is located at negative 5, negative 3. Q is located at 0, negative 1. When I apply my rules, I just have to make each number opposite. So H, and remember it's going to be H prime, becomes positive 3, positive 5. J prime becomes positive 5, positive 3. Q prime, 0 stays the same, and negative 1 becomes positive 1. Any ideas what I would do now? Hopefully you realized I need to graph the points. H prime would go at 3, 5. J prime would go at 5, 3. And Q prime would go to 0, 1. And now what I do is connect the dots. And here we have our triangle rotated 180 degrees. Here's our next example. If you already understand it, I would encourage you to pause the video and attempt this before I explain it. I need to rotate this triangle 90 degrees counterclockwise about the origin. Think back to the rule for rotating 90 degrees counterclockwise. The rule is that my xy becomes negative y, x. So I have my points B, L, S. B is located at 4, 5, L is located at 5, 0, and S is located at 2, 2. Now I need to apply my rule to each one of these points. B prime now becomes negative 5, 4. Don't forget to put your prime mark. L prime becomes 0, 5. Notice the 0 doesn't turn positive or negative, it just stays 0. S prime becomes negative 2, 2. Now I plot these points. B prime is plotted at negative 5, 4. L prime is plotted at 0, 5. S prime is plotted at negative 2, 2. And now I connect my dots. And we have rotated the original triangle 90 degrees counterclockwise. Here's our final example. Again, I would challenge you to pause the video and attempt this before you see the explanation. I need to rotate this figure 90 degrees counterclockwise about the origin, and it gives me 4 points. So the first thing I need to do is plot each point. So here's our figure plotted on a graph. Almost looks like Nevada. I guess we drew the state of Nevada on a coordinate plane. Now you have to remember the rule for rotating 90 degrees clockwise. XY becomes Y negative X. I already have each ordered pair listed, so I need to apply my rule. When I apply my rule to each point, I see that U prime becomes negative 2, negative 1. W prime becomes 2, 0. K prime becomes 2, negative 3. And G prime becomes negative 3, negative 3. Now I just need to plot these points on the coordinate plane. U prime goes to negative 2, negative 1. W prime goes to 2, 0. K prime is located at 2, negative 3. And G prime is located at negative 3, negative 3. Now I connect the dots. And there we have the original shape rotated 90 degrees clockwise about the origin. This concludes our lesson on rotations. Remember, if you have any questions, you can email me at robert.donaldson@hallco.org or send me a message on Twitter at Mr_Donaldson. Until next time, this is Mr. Donaldson.